All right, guys. What we're going to be talking about today is chords. We're going to be going over chords today and more properties of chords in circles. There's three main theorems that we're going to look at today. The first one is going to be our congruent chords, congruent corresponding chord theorem. In the same circle, or in two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if we have two chords here that are congruent and their corresponding arcs will be congruent as well. It will go the other way also. If I have two arcs that are connected to chords and the chords measures are congruent, or the arcs measures are congruent, then the chords will be congruent as well. It can go either way. We also have the perpendicular chord bisector theorem. If a diameter of a chord is perpendicular, if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc, which means the chord will be cut in half, and so will the arc connecting to that chord. So the two parts of the chord will be cut in half, and the arcs will be congruent. And the last one is the converse, the perpendicular chord bisector converse. If one chord of a circle is perpendicular to another perpendicular bisector of another chord, then the first chord is a diameter. So if we have two chords that intersect each other and one of them bisects the other and is perpendicular to it, one of the chords must be the diameter. And these are kind of the three theorems that we're going to look at today. Now, the first thing we're going to look at is using congruent chords to find arc measures. So when we look at these two circles, we know that the two circles are congruent, bless you, because the radiuses are congruent. Because when we look at circle P and circle Q, well, this part here tells me that the radius are congruent. And since the two radiuses are congruent, it means the circles must be congruent as well. Now, it also tells us something else. It's telling us that chord GF and chord JK are congruent because we have our little marks. So what that means for us is that the measure of JK is going to be the same as the measure of FG. Those two arcs are going to have the same measure. And it told us that the measure of JK is 80. So the measure of FG is going to be what? 80 degrees. Because the two measures of those are going to be the same. Any questions on any of this here so far? So let's look at this one here. In the diagram, circle P is congruent to circle Q. So we're already told that the two circles are congruent to each other. So that's helpful. And the measure of JK is 120 degrees. Find the measure of FG. So how can we find the measure of FG? It would be, yes. It would be 120 degrees also. Because JK and GF, those two chords are congruent, it means their arc measures must be congruent as well. Any other questions on this here? Awesome, it's working today. Okay. Let's keep working with this here. Now, for this first one, they told us that AB is 110 degrees. Find BC. So measure of arc BC would be 110 degrees. So we can do the same thing for number 2. Since AC is 150, it means the measure of AB should be 150 as well, yes? Why not? because we know that arc AB for this diagram and arc BC are congruent because the chord connecting those two are the same. Yes? Now this next one, they told us that AC is 150 degrees. Well, it's not corresponding to either one of those two. But we know whatever AB is and whatever BC is, they're going to be the same, yes? Do you know what the total of them all is? 360. Mm-hmm. So now I know that X plus 150 is 360 degrees. Because if I add those two lengths together, since I know that they're the same, and I add it to 150, I will get 360 degrees. So X plus X would give us 2X. So 2X is equal to 210, because 360 minus 150 is 210. Close your Chromebooks. And last but not least, we can divide both sides by 2. Mm-hmm. So the measure of AB is 105 degrees. Any questions on this here, how we can utilize this? Okay. Now we're using the other property of chords, our chord bisector, perpendicular bisector theorem. Now since JL and HK intersect each other at a right angle, so they're perpendicular to each other, we know that JL is the diameter, which means this chord is bisected in half. Because if one of the chords is the diameter, it goes through the center of the circle, and it bisects another chord, or intersects another chord at a right angle, then it's going to bisect it. So HN is going to be the same as NK. NK is 7, which means HM will be 7, yes? Well, the reason we're going through this is because why? Why would we really care about HM being 7? Right? Well, what are we trying to find? Well, one of the things we need to find is HK, yes? The entire length. So if I know one part's 7, I know the other part's 7, the whole thing has to be 14. So HK is 14. It's kind of nice to know. Now, because of the perpendicular chord bisector theorem, we know that the two arcs that compose the chord HK are going to be congruent to each other. So HJ, the measure of HJ, will be equal to the measure of JK. Because according to the theorem, it's going to cut those two in half. It not only cuts the chord in half, it cuts its arc in half. Because one of our arcs is 70 plus x. The other arc is 11x. Those two arcs are congruent to each other. Now, we can't use... Oh, I see exactly where you're coming from. Because when we went over in chapter 10.1, where we talked about the central angle being congruent to its arc measure, and the arc measure is congruent to the central angle, yes? Central angles, as by definition, have its vertex in the center of the circle. So is the 90 degrees in the center of the circle? No. So unfortunately, we can't use that theorem. because it's off the center of the circle. But because of the new theorem we have today, we can say that those two arcs are congruent to each other. So we do know that 70 plus x is equal to 11x. So what do we need to do first? Yes. Which would tell us that 70 is equal to so we subtracted x from both sides. Now we're going to divide both sides by 10, which tells us x is equal to 7. And when you're solving these here, especially when we have two things written next to each other, our multiplication, we can only undo that by division. That's the only way we can undo this, to get 10x to become just x. So our answer for this is 7, yes? What did it ask for? Find the measure of HK. Measure of arc HK. So it wants the whole thing. It doesn't just want whatever 11x is or 70 plus x. So if I took 70 plus x and plugged x into it, it'd be 70 plus 7, which is, what happens if I do 11 times 7? It would give us 77, yes? Are we surprised that they give us the same amount? No, because we said they are what? They're going to be equal. They're going to give us the same amount. So this one here is 77. This one here is 77. So the measure, running out of room, of HK should be 154 because we're adding 77 and 77 together. We're adding those two arc measures together. Any questions over any of this here? We feel comfortable with this here, yes? Awesome. Well, we'll do one more of these and then we'll move on. If you're feeling comfortable with them, we'll just do one more and then we'll move on to the next type. So when we look at this here, it's asking for two things, KH and the measure of HLK, the other side. Now, because I know that JL is the diameter, it goes through the center of the circle, and intersects HK at a right angle, it means it bisects chord HK into two congruent segments. So the length of the other chord would be 28, because we can add those two 14s together. Now at this point here, we know that these two arcs are going to be congruent as well, so 2x minus 8 is going to equal 127 minus x. So the first thing we can do to solve for the value of x, we can add x to both sides. And we get that 3x minus 8 is equal to and last but not least, right, we can divide both sides by 3, and x is 45. So we found the value of x. Now what do we need to do? So we need to put it in one of these here. We need to either put it in 2x minus 8 or 127 minus x. Which one do you all want to use? So we would do 2 times 45 minus 8. Well, 2 times 45 is 90, and 90 minus 8 is 82. And if we did it with the other one, we would also get 82. So at this point here, we would do 82 plus 82 and get our answer of 164. Question? No? But is 164 what it's asking for? Because the measure of HJK is 164, because those two added together would be 164. Now, do I need that measure? Well, yes, because if I want to know the other side, I have to subtract it from 360. So, did we absolutely need the HJK? Well, yes, because we needed to find the other side. Which means we would take 360 and subtract 164. So we get that as 196. Any questions on any of this here? Do we feel comfortable with this here? Yes. Do we need to see another example for these here? No? All right, let's look at the last type of problems we're going to look at for today. And that would be these here. So, equidistant chord theorem. In the circle, or in two congruent circles, two chords are congruent if, and only if, they are equidistant from the center. So if I have two chords that are equidistant from the center, then the chords themselves are congruent. We also have the converse of this, that I can say if two chords are congruent to each other, then they will be equidistant from the center. And it'll work out that way every single time. Which doesn't seem too interesting overall, but what we can do is we can use it to find the radius. Now they gave us some information here to start with. And the first thing they told us is that QS, or QR, is equal to ST is equal to 16. So the overall length of QR and ST is 16. And that will come back into play here in a minute. Now, because I know that QR and ST are congruent, it means that they are equidistant from the center. So that means for us that these two distances here are going to be congruent. Now, to find the radius, we first need to find out what these lengths are. Because if I can find those lengths, we can use them to find the radius. As we started talking about circles, and as you all know, the radius is the distance from the center of the circle to a point on the circle. CU or CV? Unfortunately, it wouldn't. CV is the one we would have. CV and CU would be congruent because they're going to be the distance. And it's always going to be a right angle. So the distance that we're talking about between the two chords in the center will always make a right angle with that chord. Any other questions on this here? Does anybody notice a shape that I just made with the radius in our measure so far? We made a triangle, and it's not just any triangle, it's a... So what do you guys guess we're going to end up using? Pythagorean Theorem. We're eventually going to end up using, well, be helpful if I can actually write. A squared plus B squared equals C squared. Because we're going to end up using this theorem at some point before the end of this here. C squared is going to be the radius. The radius would be the hypotenuse. Now, do we have the values for A or B? Because QU is a part of QR, yes? Well, we just said if I have a chord, right, because WX is the diameter, yes? And it intersects a chord at a right angle, correct? So that means that chord is cut in half, yes? We know that the whole thing is 16, so these two parts have to be 8 and 8. So that means one of these here, we can say A, is 8 squared. So now I just need to find out what the other side is, then we can find the hypotenuse. Well, according to our theorem we just had, 2x and 5x minus 9 are congruent to each other, yes? So we can set it up as 2x is equal to 5x minus 9. So what can we do first? We can subtract 5x from both sides. Negative 3x equals negative 9. We can divide both sides by negative 3, which tells us x is equal to 3. Any questions on any of this so far? Yes, sir.
If you plug in x being 3 for 2x is 6.
Yes.
For 5x minus 9, it's 21.
3 times 15, or 3 times 5 is?
Oh, I put in 6. Okay.
Yep. You're good. So we have this set up here, yes? Any questions on this so far? Okay. So now we just need to solve this here, yes? Well, hey, these are both numbers on the same side of the equal sign, aren't they? Can't we just plug those in? Can I do 8 squared plus 6 squared in the calculator? Yes, we can plug that in. 8 squared, 8 times 8 is 64. 6 times 6 is 36. And 64 plus 36 is 100. So the radius for this circle is 10. And that's all we have to do for this here. Any questions on this here? Probably at some point, I know I've said this, you're going to find this out that the ACT and most standardized tests love Pythagorean triples, and their most favorite one to use is 3, 4, 5, or multiples of it. Because what happens if I multiply 3, 4, and 5 by 2? What do I get? Which is what we had, yes? They like using that. They'll do multiples. They'll give you 30, 40, 50, or any kind of multiples of those there. And there's two other main ones. I believe the other one is 7, 24, 25. And I think 5, 12, 13, if I'm remembering those correctly, are kind of the three that they like using. Which you're probably thinking, why does that matter? Well, heck, if we notice right here, 6 is a multiple of 3, 8 is a multiple of 4, times it by 2, times it by 2. So C has to be 10 because it's 5 times 2, yes? And what that does is that saves us all the time of actually using Pythagorean theorem and calculating. All right, we've got one more left. I mean, there's two left on the worksheet, but I think doing one more will be good, because I think the last one's just a reiteration of one of these two. Now again, just like the one we just did, we're going to do the same thing here. In the end, we're going to end up using Pythagorean theorem, a squared plus b squared equals c squared, where c is the radius. On this one here, they told us EP is equal to EQ is equal to 12, so we know that they are equidistant from the center of the circle. And they told us CD is equal to AB. Well, CD is equal to AB because they are equidistant from the center of the circle. CD is 5x plus 7, and AB is 7x minus 3. Do we have any part of the Pythagorean theorem from the get-go? Well, yes, we are told one of the side lengths is 12. So we know 12 squared plus b squared is going to equal our radius squared. But we're going to have to solve for the other length. So that's what we're going to have to solve for first. We're going to need to solve for the other side length. And to be able to solve for that side length, we need to solve for the value of x. So we have 5x plus 7 equals 7x minus 3. And we know this is true because since the chords are equidistant from the center of the circle, the chords have to be congruent. Now, what's the first thing we can do in solving this? So we can minus 7x from both sides. Huh? No, you got it right the first time. Because since 7x is positive, we're going to want to subtract it. Because whenever we're adding or subtracting to move things from one side to the other, we would do the opposite sign. Because 7 minus 7 is 0, so it's not on the right side anymore. 5x minus 7x would give us 2x, negative 2x, plus 7 is equal to 3. Now we can subtract 7 from both sides, which will tell us that negative 2x is equal to negative 4. Divide both sides by negative 2, which tells me x is equal to 2. Yes. Yes. Thank you. Yep. Talking about that last night in my grad class. Because if I'm not paying attention, it's very easy to drop a sign. I think y'all agree with 5. Yes? I think some of y'all beat me to it. Yes? So any questions on how we got x is 5? No? So now we plug it back in. So we can plug it into 5x plus 7. So that'd be 5 times 5 plus 7. 25 plus 7 is 32. So our other side length for the triangle is 32, yes? Well, we solved for CD, yes? Is CD the side length of the triangle? What is it? CQ, yes? So we do have to divide this by 2, just like we did with the other one. which gives us a side length of 16. Because these are both going to be 16 as well as these here. C would be 20. Because we could go through and do the calculations for this here. Because 12 squared would be 144. And 16 squared would be 256, which would be C squared. And these added together would give us 400. And if we square root both sides, we get C is equal to 20. But if we notice, 16 and 12, 12 is divisible by 3, 16 is divisible by 4, because we have 3, 4, 5 right triangle. Because I multiplied 3 by 4 to get 12, 4 by 4 to get 16. So the 5 should be multiplied by 4 to give us 20. So it's one of the nice ones to know, especially if we're dealing with right triangles, using the 3, 4, 5 right triangle. Yep. So it is 7, 24, 25, and 5, 12, 13 are two of the other kind of main Pythagorean triples. Are there any questions over anything we've done so far today? Be good with this here? Be good with circles? Or chords? Okay. Do you feel comfortable?